Sorry, I was interrupted. Let's continue. So we're trying to find PIA squared, right? The first thing we're looking for is that what we can get from IAD to AIA. We can find this ratio, which means for the PD square, we already know for the PD square that we can use PIA, right, this triangle to calculate for it because we find the IAD, right, and we find the IAD to AIA, which means we already know that AD to AIA, right, and we know the length of AD, so we know the length of, and we know the ratio of AD to AIA, and we know the length of AIA, right? So we can, that means we can use all of these to calculate for the PD, right? But again, we don't know the PIA. However, PD we can calculate by another triangle, that triangle BPC, right? We know the BP, we know PC, and we know BD, we know DC. So we can find the PD. And if we equate these two formula, then we can get PIA squared, right? Once we get that, that's what we are looking for. We want to find PIA squared to be a function of PA, PB, PC, ABC, right? Okay. Now come back to what we get here. We already get that IAD to AIA equals to BD equals to BD to BA, right? Equals to BD to BA. What is BD? BD, this is A, this is B, this is C, right? BD equals to C to B plus C times A. And what is DC? DC equals to B to B plus C times A, right? And then we get here IAD to AIA equals to BD to BA equals to, here is BD, AC to B plus C divided by BA, which is C. So A equals to A to B plus C, right? That's IAD to AIA, which means AD to AIA equals to 1 minus IAD to AIA equals to B plus C minus A to B plus C, right? And we can verify this. We can verify this. How? We can look at the triangle DCIA and the triangle ACIA, right? So let's just do it. So the area of triangle DCIA to the area of triangle ACIA equals to half of DC times CIA times sine angle DCIA, right? Divided by half times, for the triangle ACIA, that is AC times CIA times sine angle ACIA, which is IAC, IACP, right? Sine angle IACP. And we know that angle DCIA equals to angle IACP, so these two cancel each other. CIA cancels, half cancels, so it equals to DC to AC. right? And this one, the triangle DCIA to triangle yeah, DC, actually it's also calculated for the same thing, right? So DCIA, DC to AC, it's still DIA to AD, right? Let's see. It's DIA to DIA to AIA, right? And what is DC here? DC is BA to B plus C, right? And what is AC here? That's B to B equals to A to B plus C, right? Still, it keeps the same, so we know that it's true. Okay, now we get IAD to AIA, and we want to and also we get AD to AIA, right? We want to find the length of AD. AD squared equals to AB squared equals to AB squared times DC to BC plus AC squared times BD to times BD to BC, right? Minus BD times DC, right? So it equals to AB squared, which is C squared times DC to BC, that is B to B plus C times A divided by A, so that is the DC to BC, and AC squared, which is B squared times BD to BC, that's C to B plus C minus this one, so A squared BC to B plus C squared, right? It equals to BC 1 minus A squared to B plus C squared, right? That is AD squared. And based on AD squared, we can get AIA squared, right? We can get AIA squared. Or we can do this. We got AD squared, right? Because AD to AIA, we have IAD to AIA, we have AD to AIA. So we know that AD to IAD equals to AD to AIA times AIA to IAD, right? It equals to AD to AIA, which is B plus C minus A to B plus C, and AIA to IAD, which is B plus C to A, so it equals to B plus C minus A to A, right? So we have AD already, then IAD square equals to IAD square equals to AD square times A square divided by B plus C minus A square, right? So that is equals to BC times 1 minus B plus C square. This one, that's AD square times A square to B plus C minus A square, right? That is IAD square. Okay, now we get everything we need. right? So for this one, we just need to make a very long equation here that PD square equals to PB square times DC to BC, right? DC to BC, BC is A, that is B to B plus C, that is PB square plus PC square times BD to BC, right? BD to BC is C to B plus C, and minus BD times DC, which is A square BC to B plus C square, right? That is PD square we find from the triangle PBC, right? And we can still find the PD square from the triangle PAIA, which is equals to PA square times IAD to AIA square, right? IAD to AIA square, which is no, not square. IAD to AIA, which is A to B plus C plus PIA square times AD to AIA, right? AD to AIA, which is B plus C minus A to B plus C, and minus AIA see what we have here. Right. It's actually AD times IAD, right? So AD times IAD is like square root of these two terms, right? Which is BC 1 minus A square to B plus C square. So this is AD square times IAD square, which is BC times 1 minus A square to B plus C square times A square to B plus C minus A square, right? Right, so we have these two equations, which means we can get PB square times B to B plus C plus PC square times C to B plus C minus PA square times A to B plus C minus A square BC to B plus C square equals to PIA square times B plus C minus A to B plus C minus BC 1 minus A square to B plus C square times A to B plus C minus A, right? And let's just simplify this first. This term equals to BC B plus C square minus A square times B plus C 1 over B plus C square times A to B plus C minus A, right? This one here, and let me just move this. So this one is here, and this equals to BC times B plus C minus A, B plus C plus A times 1 to B plus C square times A to B plus C minus A, right? These two cancels, so A equals to ABC times B plus C plus A times 1 over B plus C squared. Right? Now we can move this term back to this side. Then we get PB squared times B2B plus C plus PC squared times C2B plus C minus PA squared times A2B plus C minus see, this is negative here, right? So once we move it, here would be the positive. So minus A squared BC to B plus C squared plus, here we got ABC B plus C plus A 2 B plus C squared equals to PIA squared times B plus C minus A to B plus C. Right? So look at these two terms. This is A squared BC, this is A squared BC, so they cancel each other. Then we have ABC times B plus C. B plus C cancel 1 over B plus C, so all of this just left ABC divided by B plus C, right? And from the left side and the right side of the equation, they all have a B plus C, so cancel all of them. Then we got PB squared times, actually, let's just PB squared times B plus PC squared times C minus PA squared times A minus, plus, right? Plus ABC, right? Plus ABC equals to PIA squared times B plus C minus A, which means we got PIA squared equals to 1 over B plus C minus A times PB squared times B plus PC squared times C minus PA squared times A plus ABC. It's very interesting, right? If we remember it, that PI squared equals to 1 over A plus B plus C times PA squared times A plus PB squared times B plus PC squared times C minus ABC. Right, it's actually here. Right? Just look at two formula we derived, how close they are. Okay, now it's simple. For the OIA squared, it equals to OB, OC, OA, they all are, right? So that's 1 over B plus C minus A times R squared B plus C minus A plus ABC, right? It equals to R squared plus ABC to B plus C minus A. What is this? What is this? Let's just consider about, let's do it here. Look at this one. Look at this figure. When we do, IA is a center of side tangent circle, right? So if we do the perpendicular line from IA to AB, right? Because AB is actually tangent to this tangent circle, right? So then we got IA, let's just name this point as T, right? Then IAT is radius of tangent circle, right? Similarly, here is RA, right? And if we do here, that is RA. right? And we know that this circle equals to this circle, so it's easy to prove that this triangle is and this triangle, they're identical, right? So if we want to calculate the area of ATIAP, right? If we want to calculate the area, that would be the area of triangle ABC plus the area of this one plus the area of this one, right? The area of this one equals to this one, the RA times BT times half times 2, right? Because these two are identical, so the area would be the same. That would be half RA times BT, which is triangle area times 2, so equals to RA times BT, right? And what's the area of this one? That's RA times CP. So the total area of this would be RA times CP plus RA times BT. And look at this, CP plus BT, it's actually A, right? That makes a triangle, that makes the area of this one, the area of this one, and plus this area would be RA times A. You can see it here, right? RA times A, that's the area of this one, plus the area of triangle ABC, right? It also can be rewritten as RA times this triangle plus this triangle, right? And this one plus this one plus this one plus this one, because this one equals to this one equals to this, right? So that is RA times A plus B plus C, right? RA is this one, so the AT plus AP, because AT plus AP equals to A plus B plus C, right? That is RA times times this one and this one. That's RA times this, but these are triangles, right? So you have to times half of it, right? These two are equal. And what's the triangle area of the triangle area? How can we write it in another form? We know that as ABC equals to half of, see here, BC sine A, right? And sine A equals to half A2R, right? So it equals to ABC to 4R, right? So we got that RA times A plus ABC to 4R equals to RA times A plus B plus C times half, right? Which means RA times B plus C minus A times half equals 2. So basically we move this to the right side, equals to ABC to 4R, which means RA equals to ABC to 2R and times 1 over B plus C minus A, right? So let's put this to here again. RA equals 2 ABC to 2R times 1 over B plus C minus A. That is RA, right? So, which means 2R times RA equals 2 ABC to B plus C minus A. Which means this equation can be rewritten as R squared plus 2R times RA. Right? That's OIA squared. And if you remember that OI squared, it equals to R squared minus 2RR. Look at this. They're very close, right? Okay, that's for the OIA. And for here, we actually calculated for the radius of the tangent, radius of the tangent, side tangent circle, right? Okay, this is very useful. We put it aside. We got the OI square, and for the we got OIA square for the HIA square, right? We already know that HB square, HA square, HC square can be written as here, right? 4R square minus A square, 4R square minus B square, 4R square minus C square. So we just simply replace it here. HIA square equals to 1 over B plus C minus A times HB square, right? That is 4R square minus B square times B plus 4R square minus C square times C minus 4R square times minus A square times A plus ABC. Right? That is HIA square, which we can simplify it as 4R square, right? Because here is B plus C minus A, cancel with this B plus C minus A, so we have 4R square. And then we have the things left, that is plus or minus 1 over B plus C minus A times B to the power 3 plus C to the power 3 minus A to the power 3, right? Because here is positive, and then we have negative here, so here should be negative. And this is positive, so we have negative sign here, so inside would be the negative sign, right? So that's minus ABC. That is HIA square. Now we can calculate, and we already know that OH square, right? OH square here. We got OH square equals to this one, right? 9R square minus A square B square plus C square, right? So we can calculate OH square equals to 9R square minus A square plus B square plus C square, right? So VIA square would be half of OIA square plus half of HIA square minus 1/4 of OH square, right? It's just the same idea what we calculated before. It equals to half of this, right? That is half R square plus R times RA. And plus half of this, right? So that is 2R square minus 2B plus C minus A 1 over 8 times B to the power 3, C to the power 3 minus A to the power 3 minus ABC, right? And then plus quarter of 9r squared minus a squared plus b squared plus c squared, right? So it equals 2. Let's just collect the r squared first. Here is 2r squared. They say that equals 2. Wait. This should be minus, right? Yeah. So that is so this one is like 2 by 4 r squared, right? This is 8 by 4, so total is 10 by 4, and here is 9 by 4, so we have quarter r squared left plus r times ra, right? And then the rest part would be minus b to the power 3 plus c to the power 3 plus a to the power 3 minus a, b, c to 2 of b plus c minus a, and then plus a squared plus b squared plus c squared, right? This one time 1 to 4. Okay, now look at here. We want to prove that they are tangent, right? So we want to prove VIA squared equals to half of r plus RA squared, which is 1 to 4 r squared plus r times RA plus RA squared, right? Basically, we just need to prove that this term is RA squared, which we already get that RA squared equals to this one, right? And what is R? What is R that represented by the ABC? So the area of ABC to 4R, right? The area of ABC to 4R, it also equals to squat P minus A, P minus B, P minus C, right? P equals to half of A plus B plus C, which means we can calculate for R, right? So let's do that. The first thing is that we have the area ABC equals to squat P minus A, P minus B, P minus C, right? Which means, and also equals to ABC to 4R, right? Which means A squared, B squared, C squared to 16R squared equals to half of A plus B plus C times half of A plus B minus C times half of A minus B plus C times half of minus A plus B plus C, right? Which means R squared equals to A squared, B squared, C squared divided by A plus B plus C, A plus B minus C, A minus B plus C, and minus A plus B plus C, right? That's R squared. And we have RA equals to ABC to 2R times 1 over B plus C minus A, right? Which means RA squared equals to ABC to 4R squared times B plus C minus A square, here square, right? So we got RA squared equals to this one divided by 4R squared, right? So 4 is here, and we flip it. That is 4 is here, and we flip it, right? So, we just have 1 over 4 here times A squared, B squared, C squared, they are all cancel each other. So we have the thing left is A plus B plus C, A plus B minus C, A minus B plus C, right? And divided by B plus C minus A, right? Because one of the B plus C minus A cancels this one. So we got RA squared here. And now let's look at this again. We basically want to prove that this term equals to RA squared, right? So we rewrite it. That is okay. That is minus sign first, right? Please bear with me. So minus sign B to the power 3 plus C to the power 3 plus A to the power 3 minus ABC divided by B plus C minus A times 2 here, and plus 1 to 4. A squared plus B squared plus C squared, right? We just need to prove these two are equal, right? So for this one, it equals to 1, 2, 4. So we got B plus C minus A, and in it would be A squared plus B squared plus C squared times B plus C minus A, and then we minus 2 B to the power 3 minus 2C to the power 3 minus 2A to the power 3 plus 2ABC, right? Look at these two terms. We just need to prove this one equals to this one, right? So inside would be A squared B plus A squared C minus A to the power 3, right? And let me check. It looks like I have a sign issue. This is plus. So this one is minus here. Am I getting to correct? Yeah, it looks correct. Looks we're having trouble here because inside of it, that's this one is a squared b, a squared c, and minus a to the power 3 here, minus twice of a to the power 3, then that's 3, right? And but for here we got only 1. I think I missed something here, must be a mistake. Let me just stop for now. I will check it and let's continue later.